All right, so let's proceed ahead. Here is I use the backbone and the preprocessor. Okay, to reduce the complexity of the model. Now, you can take an optimizer, um, Adam, Adam W, whatever. There are various optimizers. Hai na? What is the task of optimization? To reduce the errors, to find the minima, to reduce the losses in a deep learning neural network. So here also I'm taking an optimizer. Okay, from Keras, I'm taking Adam W as an optimizer. You can take Adam, you can take any other optimizer of your choice. Okay, stochastic gradient descent or whatever, RMS prop, whatever you want to take, you can. Okay, you can define the learning rate, you can define the weight decay from your side. Adam W में weight decay है. You can define from your side. Okay, so optimizers here I'm taking Adam W. Okay, with a learning rate of 10 की power minus 5. Okay, very low learning rate and very less weight decay. Okay. Adam W is a variant of Adam optimizer. Adam was supposed to be the best optimizer in neural network, deep learning. Okay. And I'm taking a version of Adam, Adam W. Okay. That incorporates weight decay. इसमें weight decay होता है, बाकियों में नहीं है. Okay. So here weight decay is present in Adam W. I'm taking that optimizer. Okay. That is help me in optimization step to prevent overfitting by penalizing large weights. If there are large weights, just put a penalty and prevent overfitting. Okay, then I'm excluding the variables from the weight decay. Exclude some variables from the weight decay. That means I specified this line of weight decay in optimization. That means the variables with names containing bias and the scale should not be contained in the weight decay. उनको हटा दो आप. Exclude. Exclude those names which are having bias and the scale from the weight decay. Okay. So in common, bias and the scale parameters are used in batch normalization layer to prevent their regularization as they typically don't need any regularization technique. So just remove from there bias and the scale. In Gemma, we are having in our architecture itself, we are having the normalization. We already studied the architecture. So here I'm not considering then the bias and the scale, these two parameters in my optimization process. I'm excluding these variables from the weight decay. So I'm taking Adam W for my overfitting prevention. Okay, and excluding some variables from the weight decay. Simple. Okay, and then compile your model. So same thing as we do in general deep learning models. And a model dot compile here also same thing. Gemma dot compile. Okay, and I'm taking the losses as sparse categorical cross entropy. What is sparse categorical cross entropy? When you are having multi classification and when you want to assign integers to the target integer value, for example 1 2 3, that will comes under sparse categorical cross entropy. Okay, so here I'm doing the same thing. I'm setting the loss function for the training as a sparse, used for multi-classification, and which are labeled as integer. I'm setting logits true, indicate the model output is not normalized, that is logis. It will convert the answers into probability. I'll get the answers in probability, not into some normalized values. So that's what I'm taking. Logits true. Sparse categorical cross entropy. Optimizer is my Adam W. Weighted matrix is sparse categorical accuracy. This is what I'm going to evaluate. ठीक है तो लॉस है और सब I mentioned optimizer everything I mentioned. ठीक. Okay, so here is something which I'm going to get a weighted matrix accuracy. Okay, sparse categorical accuracy I'm mentioning here in my compilation. Then I need to do some stuff with the data. Data is this, which I took question answer data. Okay, you are having question answer data in this format. You created a data frame of it. I want to organize this thing into some format to put this data into the model for the training purpose. Okay, give it for the training purpose. Before you have to create a template. Okay, because I need to train my large language model, so I need to create a template based upon it, that this is my empty data set. That means data set is an empty list. I am applying loop over every row. That means every row I'm iterating. Okay, first index position, second index position, iterate over each and every index and the row. Okay, we are having question answer. So let me create a row of questions, let me create a row of answers, and give them in a form of a template like this. Here is the question, here is the answer for it. So question, answer, and append this in a form of a append this template in my empty list. That's what you have to do. So there will be a list, there will be a list of question answer. Okay, how it will work? जैसे क्या होगा? You will be having question, what is your name, what is your name? So question colon, what is your name? Answer colon, my name is Nirmal, comma. Another question, where do you live? I live in Bhopal, MP, comma. Certainly this is how I have created data. So you can create your custom data from your side. Your data set you can create, make a question answer of yours yourself, and perform this thing and train Gemma model over it. So you will create your clone. Do this thing, you will be creating your own clone for that. कर सकते हो वो बनाना जरूर. Okay, so I am doing this thing. Fine, data set करा, and I fit the data into model for training. कर दिया, fit the data into the model. 10 iterations तक I worked. Okay, for 10 iterations I did. ट्रेन हो गया मेरा मॉडल. एक्यूरेसी देखो आप 90 तक, टिल 90 accuracy came. Then I did one more thing from my side, because I need to print the plots for this trend model. Okay, so that's what I need to do. How much did it take for the 10 epos? Not that much time, because my data set was very less. Okay, not so much big data available with me. You can see I printed my data, and the data is only of 166 rows. Okay, very small data. Okay, so it didn't take too much time. Okay, if your data set is huge, so it may take, but for this it didn't take too much time. Okay, so I trained my model for 10 iterations. Ho gaya. But you know what I did next? I converted my data into array. I converted my data into array, which was actually a list. I converted into an array, numpy array, and then I retrained with validation split. That means 20% data I took for the validation, and 80% of the data I took for the testing. I did this task. Okay, so it's just an excuse for you guys. Okay, you can take any data from your side and perform this question answering stuff, fine tuning. Okay, this is an additional thing which I gave you from my side. Okay, that you can split your data into training, testing. Okay, fine. So I just retrained this with only 5 epos. हालांकि मेरा हो गया था यहाँ पर. I already finished my training here. I can perform the prediction after that. But what I did, I converted my data into array format, and then again I took history one equal to Gemma dot fit, and I took with a validation split with 5 epos. ये कर दिया. Then I draw the plot for history. हिस्ट्री वन का प्लॉट बनाया मैंने. लॉसेस का, ट्रेनिंग लॉसेस, वैलिडेशन लॉस, ट्रेनिंग लॉस, ट्रेनिंग एक्यूरेसी का प्लॉट बनाया. दीज आर द प्लॉट्स विच आई क्रिएटेड. एंड यू कैन सी कि सर लॉसेस बढ़ रहे हैं. ओके, लॉसेस आर गेटिंग मोर एज द इटरेशंस आर गेटिंग मोर, एंड एक्यूरेसी इज गेटिंग लेस ऑल्सो. ओके, बट डजेंट मैटर, ये आपको कहीं मिलेगा नहीं, मेरा ही है. ठीक है. आई थॉट दैट इफ यू आर गोइंग टू यूज जेमा मॉडल फॉर योर रिसर्च पर्पस, और इफ यू वांट टू फाइन ट्यून योर विद योर क्वेश्चन आंसर डेटा वट एवर, तो आप क्या कर सकते हो, व्हाट यू कैन डू विद दिस, how you can draw some plots and show the results. Okay, so this is certainly a technique which you can use from your side. I did converted my data into the array format and I retrained my model, क्योंकि जब मैं डायरेक्ट डेटा सेट ले रहा था वो लिस्ट थी, तो लिस्ट से इट इज नॉट गिविंग मी द हिस्ट्री एंड ऑल दिस थिंग्स, वो दे नहीं रहा था, वो इशू कर रहा था. So I converted into array format and then I performed the splitting, and then वो उसने मुझे दे दिया plot. Though it seems to be overfitted, you can see overfitted नजर आ रहा है यहाँ पे. Anyways, यदि आप इसको नहीं कर रहे, for example, you can ignore this code also. Okay, this I did for my purpose to show the plot, to show the results. If you want, you can ignore it. Don't convert the data into array. Don't train your model with this array, with the validation. Don't plot the results. Okay, because zaruri nahi hai, but I did from my side. And then after training, I can use my model for questions, for data science questions, because I have trained my model with the data science questions. So I this is the first question. What is confusion matrix? It is, these questions are present in my list of data set. So I can ask to my trained model, what is confusion matrix? It will answer me. ये फाइन ट्यूनिंग हुई है मेरे मॉडल की. And I'm having a set of data science questions there, so I can ask any question accordingly. What is confusion matrix? What is significance of p value? What is a bias in data science? So you can ask to your model and it will generate and reply. ये फाइन ट्यूनिंग हो गई आपकी. Okay, so this is how we did a fine tuning. Results we publish kara, we did publish the results, and you have seen that Gemma model is quite, comfortable to use, not complications at all. What are the changes? What are the architecture? Okay, what are the components there? What is its significance? Use LORA. I did explain everything, and we did a fine tuning of your Gemma model here. And these are the results which are coming. I've already run. I'm not running again. Okay, so these are the results which I got. Okay, you can fine tune your data using Gemma in this approach. Question answering. Okay, so here is the code for that. Question answering, fine tuning, Gemma model. Okay, but we are not. Yes, yes, please say. Yes, sir, ask the question.
Sir, is there, can we generate any questions that is not included in your data set?
Sir, you can give a question, you can get an answer for that, sir. That's what we have fine tuned our model for.
No, nothing like, can we generate something, the questions which are not in the data set? For example,
Uh-huh.
if we say suppose just figure the diameter of the earth is this much,
Mm-hmm.
and if I'm asking what is the perimeter of the earth,
Mm-hmm.
so can it give me the answer after generating that one, or only the questions that is
So
given
questions
in the
related
data
to
set can
data
only be
science, sir,
provided?
only, sir, because we have fine tuned our model. So we expect that our model is going to give the response according to the fine tuned data, sir. In general, if it was not fine tuned, then sir you can ask what is the diameter of the earth, what is the radius of the earth, and what etc etc. That you can do any science questions and whatever, any coding question. Okay, whatever you want to give, you can give from your side. Here I have fine tuned my model with respect to the data science
Because
questions.
no, because when we had done some projects in ChatGPT, since I think the temperature value you're giving us one,
Huh.
so it have its own imagination, right? The other things like when you just reduce the temperature value,
Temperature value,
that is
yes sir.
the
Sir,
specific questions,
temperature,
right?
yeah, yeah, these are the parameters, so it will give you the variation in the answers. So temperature.
Yes.
So
Similarly, can we do the same thing here?
sir, we can do here also. We can do in Gemma. Okay, so these are the parameters which we do use to show the variations from 0 to 1. This is the value of the temperature. So to get the such kind of results, for example, we have used one thing, sample. We have used one thing here, that is the sample. Okay, I hope you remember this thing, sampling. So sampling gave us a result that is top k, and k value you can give from your side. Okay, so what we did, the top k sampling involves selecting the next token which is likely to be present, and the k is a predefined hyperparameter. Similarly, temperature is also predefined parameter. Top k is also predefined hyperparameter. You can give the value of k and you can find which is the best possible word or which is the best possible token which I can use in a sentence. So that's what you can do. So top k is one of the hyperparameter which I've used to show you while text generation. And here we have fine tuned our model with respect to the data science questions. So if you are having any data related to the data science, you just do this thing. Okay. And I told you create your questionnaire also and train this model by your questionnaire. In this approach, what I did. Okay, fine. So that will be one of the trial case for you.
Sir, yeah, one more question I can ask. Suppose if you're giving some statistical, for example, say we say have what is the variance, and we haven't asked for something like standard deviation. We haven't
Hmm.
trained, or we
Yes, sir.
don't have the data set having standard deviation.
Hmm.
So whether that can generate the standard deviation from the
So,
variance,
yes, sir. It will
even if
generate.
it is not feeded in the data set.
It will generate, sir. And one more thing, if you are having a question which is out of the scope, sir, you can mix it with your fine-tuned data. Do this thing, because in my data set, if there is any question which is not available, okay, you can mention here in your data. If the answer is not there, any question, any question, you can put it here. Okay, and you can say this answer is not available, something like that you can do. Okay, so accordingly it will give you the answer. Okay, you can give a question
Okay.
or something like that, and you can mention the answer that it is out of the scope, so it will learn accordingly. Right now here I am giving the questions: regression, supervised learning, linear regression, all these things I'm giving from my side. Okay, so on the basis of this data only my model is trained.
Okay. Got it.
Okay,
Thank
sir.
you.
Okay.
But sir, one thing, if we don't do this gamma dot fit like we did below, I
Hmm.
think it will answer to general questions as well,
हाँ,
right?
जनरल क्वेश्चन इट विल आंसर देन जनरल. इफ यू
Hmm.
डोंट डू द सी
Yes, yes.
फिटिंग का तो ये काम होता है ना. आप अपने मॉडल सी इट्स जस्ट लाइक as which we do in our machine learning and the deep learning, same thing is happening here. What we do in
Yes,
ml
yes.
and dl, model dot fit only na. We do the
Yes,
model
yes.
dot compile for deep learning, and we see this is the architecture. Gemma architecture I've already taken. Then I'm compiling my model. Okay, and then I'm fitting the data with my custom data, and I'm training my model dot fit. That's what I'm doing. तो वहां पर क्या
Yes.
होता था, विच काइंड ऑफ रिजल्ट आई एम गेटिंग, जिससे डेटा को ट्रेन करा था उसी के अकॉर्डिंग इट विल गिव यू द रिजल्ट. यहाँ पर भी यही हो
Hmm.
रहा है, उसी के अकॉर्डिंग इट विल गिव द रिजल्ट. नाउ इफ यू आस्क समथिंग जनरल, यू कैन डू दिस थिंग. आई विल शेयर द कोड विद यू ऑल. Okay, you can try, you can custom, you can edit my code, and you can check if you are asking any other question apart from the trained data, what it is responding. You can check out from your side कि फाइन ट्यूनिंग के बाद इफ आई एम आस्किंग समथिंग एल्स वेदर इट इज रिप्लाइंग करेक्ट और नॉट, करके चेक करके देखिएगा. But I'm trained my model with my specific data for a specific task, so it will respond to that accordingly. My weight are readjusted now. यदि आप उससे अब कुछ और पूछोगे तो वो कुछ और देगा. It will reply something else जो कि शायद मेरे लिए कंफर्टेबल ना हो. Okay, so that's what it happens in model dot fit. Okay, so I did that. Okay, so here is some plots, and here are the results which I asked. What is confusion matrix? What is significance of p-value? What is bias in data science? Some experiment are been there and which has been printed. You can change the question of the data science, and then you can put it here and check how it is responding. कर सकते हो आप. Okay, now one more important code I want to show you. Okay, and that code is fine tuning of 7b. Fine tuning of 7b. Okay, so wait a second, let me. Okay, just a second, I hope you will be able to see it in a better way. Okay, fine tuning of 7b for sentiment analysis. Okay, now I'm having 7 billion trained parameter Gemma model. So I already told two types of model you are having, 2b and 7b. I use 2b initially for question answering, fine tuning. Now I'm using Gemma 7b for sentiment analysis. another code. Okay, we'll just take a review of it, what we are doing in this particular segment. So क्या हुआ, uh, fine tuning of 7B sentiment analysis. In this tutorial, we are having a sentiment analysis data based upon financial and economic information. So, we do sentiment analysis by our general machine learning and deep learning models. Now, how Gemma can be used for sentiment analysis? That's the question. How we can use it? Okay, so I'm having a financial data, financial and economic information data. We can use sentiment analysis for it. Okay, वो करना है हमें. Fine. So this is the data set description which we are available with. Okay, you can read it, the complete data set description, what has been there. I am having finance and economic text, annotated data, okay, which is having already sentiment present in it. Okay, and there are certain issue also, and they have been addressed here by Alto University School of Business. In 2014, they took 5,000 sentences, okay, of the data, 5,000 sentences. So there is a collection of 5,000 sentences, 5,000 rows data which are annotated with a sentiment. Okay, and this collection aimed to establish a human annotated benchmark serving a standard elevation alternative modeling technique, okay, related to your finance and something. Okay, उसमें क्या सेंटिमेंट निकलता है उसका डेटा सेट है ये. Okay, and 16 people annotated this data. They are involved, and this data is manually annotated, 5,000 rows, and 16 people annotated this data. Okay, and they give a sentiment as positive, negative, or neutral based on the stock price, whatever be the text, and accordingly they have annotated sentiment positive, negative, and neutral. And क्योंकि financial है, this is financial, so it's related to the stock, something like that. Okay, ये करा है उन्होंने. So I am having news headline and I am having a sentiment. दोनों है मेरे पास, न्यूज हेडलाइन एंड द सेंटिमेंट. ये डेटा है मेरा. Okay, and the first thing is you have to install the libraries. Okay, so I'm going to take accelerate library, peft library, bits and bytes library, transfer library, trl. All these I need to install. These are big ones. Okay, accelerate, pft, bits and bytes, transformer, and the trl. ये install करना है आपको. ये रहा. First you have to install all these. So I'm installing torch, I'm installing transformer, I'm installing accelerate, this library. What does this accelerate library means? Okay, let me tell you about this accelerate library also. See, you know what is the case, because if you are having a huge data, huge model you are using, and I'm training my data with the multiple GPU, so I want acceleration, I want quick training. Okay, तो accelerate क्या करता है मुझे? Accelerate will help me in faster training of large models. Okay, or the multiple GPUs. So ये distributed कर देगा. It will help me in distribution of the data and quick training का मुझे help करेगा ये. So that's why I'm using accelerate. Okay, I hope if you have done a project session with me, when we have fine tuned llama 2, we also did a project session on llama 2 fine tuning, जो मेटा का था. वहां पर भी एक्सेलरेट लिया था हमने, एंड रेस्ट ऑफ द लाइब्रेरीज भी लिए हमने, बिट्स एंड द बाइट्स, pft, trl. These libraries are also we have taken there in llama 2 fine tuning. Same libraries are present here, same are present. Okay, so I took accelerate for distributed computing and quick results. ठीक है, और फिर मैं ले रहा हूं, आई एम टेकिंग बिट वाइज, बिट्स एंड बाइट्स, बिट्स एंड बाइट्स. ये गजब खेल है. Bits and bytes, what bits and bytes is doing, you know this library will convert different data types such as integers, bytes, and hexadecimal strings into some specific format, okay, to perform the computation. बिट्स एंड बाइट्स यानी कन्वर्जन होगा आपका, जो भी डेटा टाइप है। ओके, टू परफॉर्म टू परफॉर्म योर कंप्यूटेशंस ऑपरेशंस। ठीक है, जैसे कि यू कैन टेक बिट्स मल्टीप्लीकेशन, you can take bit checksum. Okay, there are many things which you can, which you can take any kind of operation like x or या any gated operation if you want to apply, ये आप कर सकते हो। तो बिट्स एंड बाइट्स बड़ी इंपॉर्टेंट लाइब्रेरी, वेरी इंपॉर्टेंट लाइब्रेरी। फाइन, सो आई कैन परफॉर्म बिट वाइज ऑपरेशन, बड़ी बात है, ध्यान रखना, जस्ट रिमेंबर, आई कैन परफॉर्म बिट वाइज ऑपरेशन, and, or, XOR, not, over binary data. So it will transform the data into binary format, and it can perform binary level operations. ठीक है, binary operations it can perform. Okay, very important. So you can have an integer data, you can have a float data, convert it into binary and perform the operation bitwise. तो आजकल in the heavy models bitwise operations has been done, फ्लोटिंग पॉइंट में कन्वर्ट करो, बाइट्स में कन्वर्ट करो, बिट्स में कन्वर्ट करो, एंड डू दैट। ओके, दैट्स व्हाट आई कैन परफॉर्म। सो बिट वाइज ऑपरेशंस के लिए बिट एंड बाइट लाइब्रेरी इज बीन यूज्ड, वेरी इंपॉर्टेंट। देन आई एम टेकिंग अ डेटा सेट बिकॉज आई विल लोड already sentiment data set which is available in data set, I will pick that. So I'm taking data set, then I'm taking TRL and PEFT. Okay, what are these TRL and your PEFT? So TRL means your training loop abstractions. Training loop abstractions. That means it provides a high level interface for training machine learning, deep learning models, and such kind of models. Okay, high level of interface for training. It provides abstraction. ठीक है, to capture the complexities of the training. ठीक है, मुझे इंपॉर्टेंट एब्स्ट्रैक्शन क्या होता है, व्हाट इज एब्स्ट्रैक्शन? एब्स्ट्रैक्शन मींस जस्ट टू कैप्चर इंपॉर्टेंट डेटा, important things. So I am using TRL, training loop abstraction. When the training will be going on, I am going to perform the abstraction. I am going to inherit some important features which are present during the training, so that I will do using training loop abstractions, TRL. Okay, ये काम करेंगे। And I am having PFT, that is positional encoding. So this positional encoding is already present in my Gemma. So PFT is positional encoding Fourier transform, PFT. ठीक है, तो it can perform positional encoding using Fourier features, Fourier transformation technique. ये positional encoding करेगा। ठीक है, according to the periodicity of the occurrence of any word in a sequence. तो आपसे बोला था ना एनकोडिंग करना है, पोजिशनल एनकोडिंग करना है, कैसे करोगे, हाउ? सो यू हैव टू यूज सम मैथमेटिकल अप्रोच टू परफॉर्म द पोजिशनल एनकोडिंग। तो पीएफटी लग रहा है, तो किसी भी वर्ड के ऑकरेंस होने की, व्हाट इज द फ्रीक्वेंसी ऑफ ऑकरेंस ऑफ एनी वर्ड, what is the periodicity, what is the pattern which has been followed in a sequence, accordingly you encode that particular word. This is done by PFT, positional encoding. So PFT is positional encoding with Fourier features, with Fourier transformation, Fourier series. Okay, that's what we study in our maths. यानी it can be sinusoidal, साइन कर्व हो रहा है, तो वो एक फ्रीक्वेंसी चेक कर रहा है उसकी, कौन सा वर्ड, विच वर्ड इज कमिंग इन विच सीक्वेंस, विच पैटर्न इट इज रिपीटिंग, सो अकॉर्डिंगली उसकी पोजिशनल एनकोडिंग कर दो, एम्बेडिंग यू हैव टू डू। तो भाई ये सब खेल है यहाँ पर। ओके, सो आई एम गोइंग टू इंस्टॉल ऑल दीज लाइब्रेरीज आफ्टर इंस्टॉलेशन। Okay, after installation, again set an environment. Okay, so I am saying CUDA. Okay, I am saying just make CUDA parameter efficient tuning or positional encoding. That's a question which came with I am doing here PEFT. Okay, then PEFT is positional encoding. It is positional encoding using Fourier. That means I'm going to talk about the frequency of occurrence of any word in a sequence of data, what pattern it is following, how often it is used in a sequence. That's what I'm doing. That is positional encoding, PFT. So capturing the periodicity of a data. Okay, that will help us in understanding the positional relationship between the tokens. That's what I said. If I'm saying my name, so how often my and name come together, how often they come together, that is positional encoding. ये मैं देखना चाह रहा था. How often my and name come together. Okay, so I want to keep track of a note of this thing. So this is positional encoding. Okay, I tried to increase this size of the screen, but unfortunately it is, I hope, please kindly manage. Okay, so next I'm having import os, os environment, CUDA and all these things. That means I'm considering this os environment. Okay, and in this os environment I'm taking CUDA, that is compute unified device architecture. I'm setting up the GPU. Okay, I'm taking the device 0, the first GPU I'm taking, okay, for the processing. That's what I'm taking. And I'm saying that there should not be any parallelization. Okay, no parallel processing will be there. So I'm setting up the environment like this way. Okay, and then I'm importing warning in case if any if this is exceptional library. Okay, if you want to use you can, if not ignore it. Okay, so far I have imported the libraries apart from Gemma. I'm using supporting libraries. Okay, and then here I'm importing NumPy, Pandas, OS, Torch, Transformer. From Transformer, I'm taking Auto Model, Causal LM. है ना, Auto Model, ये Causal LM. I hope you remember this thing. Causal Casual. Okay, Causal LM. So I'm importing from Transformer, Causal LM, its tokenizer, bit and byte configuration, trainable arguments, pipelining, and the logging. All these I'm taking. I'm also importing LoRa configuration and PFT configuration, taking the data sets. And I'm taking, because I'm going to use PyTorch here for the training. Previously I used Keras. Now I'm using PyTorch for the training. So I will be taking SFTT trainer. SFT trainer. That's what I will be taking here. So अभी मैं PyTorch का use करूंगा for training. Previously I used Keras for the training. Okay, fine. So here is the case. ये सारा libraries I'm importing. Okay, so if I hope you have some idea, some knowledge about these libraries. Torch is an open source machine learning library. I am importing neural network from the Torch. You can see from your side. I am taking Torch, neural network from the Torch. I am importing Transformer. Okay, and Transformer obviously. Okay, it's a Hugging Face library, state of the art architecture. From Transformer I'm importing Auto Model, automatically loading pre-trained causal model को import कर रहे हैं. I'm taking tokenizer to tokenize my sentence. Bit and byte I'm taking. I already explained what is bit and byte. Okay, training arguments, what should I'm going to set, वो ले लिया. Pipelining ले लिया. Okay, and logging ले लिया मैंने. Logging logging messages during model training and the evaluation, उसके लिए logging लिया. ओके, तो ये सारा हमने ले लिया. ठीक है. सो आई एम टेकिंग द ट्रेनर एंड द बिट्स एंड बाइट्स एंड ऑल दिस कॉन्फ़िगरेशन आई एम टेकिंग फॉर द ट्रेनिंग पर्पस. एंड ये आपका मॉडल इवैल्यूएशन के लिए. For the classification, you are having a sentiment data, positive, negative, neutral. So you have to train and then you need to print the confusion matrix, classification record, accuracy and etc etc. ये करना है आपको. तो बस छोड़िए, फिर कोई इशू नहीं है, डेटा सेट उठाओ. सो दिस इज द मॉडल नेम. दिस इज द मॉडल नेम, हियर इज द पाथ ऑफ द मॉडल 7B. सो मॉडल का पाथ यहां से यू कैन टेक 7B. ओके, 7B मॉडल ऐड करा है, वर्जन 1. ओके, सो यू कैन टेक अ पाथ ऑफ द मॉडल, कॉपी पेस्ट कर दो यहाँ पे, बस. और उसके बाद ये चीजें इंपॉर्टेंट है अब. सेटअप द कॉन्फ़िगरेशन. ठीक है, सेटअप द कॉन्फ़िगरेशन. ओके, तो क्या करा है यहाँ पर, दैट्स व्हाट वी हैव टू चेक आउट. ये वाला कोड इंपॉर्टेंट है. Okay, so what I am doing here, I am loading my model and I am configuring my bits and bytes. That means I am defining the data type for computation, which is 16-bit floating type. आप देख सकते हो यहाँ, I am defining my data which is 16-bit floating type. Okay, that's what I am doing. And then I am configuring the quantization process. Okay, that means I am going to load model weights which is present in 4-bit format. ये मॉडल के वेट को 4-bit फॉर्मेट में लोड करो. ठीक है, दैट्स व्हाट यू हैव टू डू फ्रॉम योर साइड. देन आई नीड टू डिटरमाइन द यूज ऑफ डबल क्वांटाइजेशन. ठीक है, दैट मीन्स डिटरमाइन वेदर टू यूज डबल क्वांटाइजेशन और नॉट. तो डबल क्वांटाइजेशन में नहीं कर रहा हूं, आई एम नॉट क्वांटाइजिंग फर्दर मोर, आई एम जस्ट लोडिंग माई मॉडल वेट्स इनटू 4 बिट्स एंड आई एम सेटिंग फॉल्स फॉर द डबल क्वांटाइजेशन. मैं फॉल्स कर रहा हूं. Then I am specifying the quantization again, that is BNB 4-bit quantized type equal to NF4. That means 4-bit weights को सेट कर दिया और मेरा डेटा टाइप जो कंप्यूटेशन के लिए होगा वो 16-bit होगा. इतना काम करा है बस. ठीक है, सो ये मेरा 4-bit क्वांटाइजेशन प्रोसेस के लिए मैं आगे बढ़ रहा हूं. टेक द 4-bit एंड दैट 4-bit इज बिन यूज्ड फॉर योर बिटवाइज ऑपरेशंस. बस वो ले लो आप. तो 16-बिट का कंप्यूटेशन होगा, वो तो 16-बिट का आप ले लोगे, इनपुट लोगे. मॉडल 4-बिट का लोड कर दिया आपने. ओके, दैट्स व्हाट यू हैव टेकन. ऑल राइट, ये काम करा. एंड देन यू कैन लोड योर मॉडल प्री ट्रेन एज वी डिड प्रीवियसली विद Gemma 2B. Okay, that's what we have done. So take your pre-trained model. Mapping auto है. Okay, auto mapping of the data. And this is the quantization process which you are doing. तो ऑटो मैपिंग क्यों करा था मैंने, वो डेंस रिप्रेजेंटेशन में ना, दैट्स व्हाई ऑटो. सो यू आर लोडिंग योर मॉडल, दैट इज 7B मॉडल. ओके, बस ये कर दिया आपने. सो यू हैव टू assign your quantization process and then you have to use your model. Okay, टोकनाइजेशन भी ले लीजिए आप. ओके, यू हैव टू टोकनाइज योर डेटा, है ना, टोकनाइजेशन भी करना है आपको. ओके, तो यू कैन टेक ऑटो टोकनाइजर. फाइन, दैट्स व्हाट यू हैव टू डू. सो दिस इज द setting which I have to perform. Okay, this is the setting which I need to perform. Fine, and after that you can take your data, you can create your data frame. Okay, do all these activity, prepare a list of your data. There are few things, positive, negative, neutral. ये आप एक उसकी empty list बनाइए, because I'm going to split my data into training, testing. So prepare a list of X train, X test, and apply a loop over sentiment and take training size 300, testing size 300. You can take from your side. ये आप कर सकते हो, कस्टम कर सकते हो आप. यू कैन क्रिएट कस्टमाइजेशन फ्रॉम योर साइड. क्रिएट अ ट्रेनिंग एंड द टेस्टिंग डेटा, ये आप कर लीजिए. ओके, ये पूरा काम मैंने यहाँ पर मेंशन कर रखा है. फाइन, एंड देन ये पूरे प्रॉम्प्ट उसके लिए क्या रिक्वायर्ड है, ये आपको पूरा मैंने यहाँ पर मेंशन कर रखा है. सिंपल, अभी डेटा के साथ वर्क हो रहा है. ओके, फाइन. तो क्रिएट ट्रेनिंग डेटा एंड द टेस्टिंग डेटा. ओके, परफॉर्म कॉन्कैटिनेशन ऑफ द ट्रेनिंग डेटा. ओके, परफॉर्म द शफलिंग ऑफ द रोस. ये आपको यहां पर करा है मैंने, कॉन्कैटिनेशन करा है ट्रेनिंग का और उसकी शफलिंग कर दी है. आई डिड परफॉर्म द शफलिंग, ताकि मुझे एक ऑर्डर में ना मिले सेंटिमेंट, पॉजिटिव, नेगेटिव, न्यूट्रल. आई डिड परफॉर्म द शफलिंग ऑफ द डेटा. if you want you can, if you don't want, don't do. You can simply split your data into training, testing also. वो भी इतना भी कार्यक्रम करने की, you do not have to require all these things, not mandatory. You can simplify the task which I believe, which you believe that sir it is a bit hectic. So this is the data set you are available with. Text है, sentiment है. Okay, it is available with you. Okay, you can directly split into x train xs, y train y test, डायरेक्ट कर सकते हो और मॉडल के अंदर ट्रेनिंग के लिए दे सकते हो. Don't apply the techniques which I have used, shuffling करना, ये करना मत करो. Do the simple process which you do in machine learning or deep learning of data splitting. ठीक है. आई ये थोड़ा सा कुछ और इसके अंदर फर्दर एक्सपेरिमेंट्स करे गए हैं, तो आप चाहे तो अवॉइड कर सकते हैं इफ यू आर नॉट एबल टू अंडरस्टैंड. ठीक है, कोई बात नहीं. तो ये सब शफल करने के बाद, ओके, शफल करने के बाद आई विल स्ट्रेट फॉरवर्ड जा रहा हूं कहां पर, यहां पर आइए. ओके, दिस इज व्हाट. अच्छा चलो ठीक है, देर आर फ्यू स्टेप्स, उसको भी मैं पहले क्लैरिफाई करूं. लेट्स टॉक अबाउट सर्टेन मोर स्टेप्स विच आई हैव यूज्ड हियर. So in this particular case, I defined two methods: generate a prompt and generate text to prompt. टू मेथड्स, ये आपका पूरा डेटा एक्स टेस्ट एक्स ट्रेन ये पूरा तैयार हो गया, शफल हो गया, एवरीथिंग इज बिन रेडी विद यू. Okay, then what I did, I generated prompt. That means I defined a function that can take your data, okay, and then it will construct a prompt that is of a headline, news headline, and a sentiment label is extracted from it. Okay, and the prompt is formatted. Okay, and finally the end of string is appended to the prompt. इतना करा है. मतलब आपका टेक्स्ट ले लिया, उसका सेंटिमेंट ले लिया. दैट्स इट. टेक्स्ट टेक द टेक्स्ट एंड इट्स सेंटिमेंट. सेम एज यू डिड with your question answering. You took a question, you took an answer, then you took a question, then answer, question, answer. Similarly, I need to convert this complete stuff into text and a sentiment. So same thing you did with the question answering. That means you created an empty list. In empty list, you gave a prompt that text colon, just do it here. Text colon, take the complete text, and then sentiment colon, take the sentiment. दिस इज हाउ यू हैव टू डू. तो आपको यदि जेमा के अंदर फाइन ट्यूनिंग के अंदर डेटा देना है, तो उसका एक फॉर्मेट है डेटा को देने का. ओके, एज यू डिड इन द क्वेश्चन आंसरिंग, सेम थिंग यू हैव टू डू विद हियर ऑल्सो. एक उस फॉर्मेट में कन्वर्ट करना पड़ेगा आपको. तो वही फॉर्मेट है यहाँ पर. ठीक है, इन दैट पर्टिकुलर फॉर्मेट आई एम गिविंग. ओके, और देने के बाद आपका ये एक्सट्रेन एक्स इवेल्युएशन का बन गया. ओके, ये पूरा जो है डेटा सेट ट्रेनिंग इवेल्युएशन, ये सब जो है अलग से तैयार किया गया है. उसके साथ साथ ऑल द डिटेल्स आई मेंशनड हियर इन द नोट्स. ठीक है, एवरी डिटेल आई हैव मेंशनड. ओके, related to it. Fine. All right. And then I already took Gemma model. ठीक है, I already took a Gemma model from above. ये देखिए, I already have a model. I performed, see, I performed the training with Gemma. यहाँ देखिए, here it is. Wait, this is my training and evaluation data, and okay, classification confusion metrics for the evaluation. Okay, and this is for the prediction. Okay, let me show you the model prediction, model training. Okay, I did it. Did just a second. These are the labels. This is the mapping. Okay, and this is classification and confusion matrix printed. Let me talk about. Wait a minute. Okay. Okay. This is mapping, Y prediction, accuracy scores. Then, huh. Here is what you have used: model, which I have taken from above. Auto casual, this not casual, causal LM 7B. Okay, so अभी तक यहाँ इस पर्टिकुलर कोड के अंदर I know that you are getting some trouble related to it. Okay, but take it very simple. What I did, I am having a data. I want to split into training and the testing. I want to shuffle the data. I want to convert the data into a format which I can give into a model for the training purpose. So I give a prompt, and then after that, I gave these instructions to it. Okay, after giving this prompting, this is my training data. ठीक है, this is my evaluation. Okay, I converted sentiment. This is my test data, and here I created train data from X train and evaluation data from X evaluation. That's all I did with the data. So I'm just doing the stuff with the data to calculate all these things: mapping the sentiment labels, calculating the accuracy of the model, generating the accuracy for the sentiment label, classification, confusion matrix. For that, I'm doing. Okay, fine. The most concerning part is here. Here, using PyTorch for training. Okay, so here I defined PEFT, positional encoding configuration. This is LORA alpha 16, LORA dropout 0. Everything let me explain you. LORA alpha, that means the value of alpha gating mechanism. That was alpha means. Dropout is a dropout probability for LORA. R is the reduction factor, bottleneck layer. So these are the terms which are already present, okay, in my model for the training. R is your reduction matrix 64, bias none, task causal LM. Okay, and these are the target modules. And we have seen this target modules in the architecture: Q, K, V, three components we have seen in the target. When you give a sequence of the data, that will break into components for attention mechanism. Okay, so these things: projection, K projection, Q projection, V projection, O projection, these we have seen in the architecture which I was explaining you before. So ये मुझे PEFT के अंदर देना पड़ेगा, पोजिशन एनकोडिंग के अंदर. And then these are the trainer arguments. These are the log directory. I gave one iteration only, one training I gave. Checkpoints, whatever I'm going to find out during training, that I will save. Checkpoints I will keep. Okay, batch size is 4, giving the data into 4 batches. Gradient accumulation also, if I want to accumulate the gradients, del L by del W. Okay, if I want to accumulate that, so just in every 4 steps accumulate the gradients, save the gradients. Not for every step, after every 4 step accumulate the gradients. Okay, this is optimizer, Adam W, 32-bit. Okay, no steps will be saved. Logging steps will be 24. Learning rate you can define. Weight decay you can define. FP16 and BF16. That means floating point representation of the data. Okay, so 16-bit floating point representation of the data you can keep. Okay, rest is as usual. If you want, you can study from here. I am having floating point representation. I am having gradient normalization. I am having evaluation strategy, evaluation steps, rate scheduler, report, everything I am present. And this is my TRL, trainer, loop trainer. Last one is the loop trainer. That means give your model, that is 7B model, give your training data, give your evaluation data. So whatever you did in between, that is not mandatory. If you face any difficulty, it's not at all mandatory. The only thing which you can do, don't get confused here, not at all. You have taken your data frame, convert it into trainable data set format, which you did with the question answering, convert into that format, and come and go ahead with this straightforward. Rest beach वाला सब छोड़ दो, ignore everything, go ahead with this thing. Just prepare a data set, okay, and give the data set here. Split your data into training and the evaluation. It's up to you. You can split from your side. Training and the evaluation. Divide it. Train and the evaluation. Rest is fine. It will take some time for the training, and that's it. Okay, यहाँ पर train होगा. Trainer dot train. Model will gonna train. And you can save your trained model. ठीक है, it will train, then you can save it. Fine. Later on, you can perform the predictions. Okay. So right now accuracy is coming for me as 0.83, 0.84. Accuracy is coming after training for sentiment analysis. Okay. So here is the classification report, confusion matrix. You can draw the heat map also for it. Okay. So what you have to do is simply take your data, divide it into training and the testing, and use this configuration for training. That's it. Here you have to train. Here you have to train and save your model. Okay, that's it. You have to do. Okay, I took this code as an additional code to give you a path, a way, an approach how you can use Gemma for sentiment analysis. Also, that was not mentioned in my template. I haven't mentioned this thing in my template, but there are few terms which I want to explain, which everyone faces a difficulty. That is bit and a byte, PFT, TRL. These are the configurations which I have to use. Okay, so LORA, low rank adaptation. So these are certainly an issue that the people face. So people don't know what is bit and the byte. Okay, what is this LORA? What is PFT? What is TRL? So people are having an issue related to it. So I just these things, and using PyTorch, how you can perform the fine tuning of a model. That's the reason I have included this code. However, that was not mentioned in the template. Okay, to perform sentiment analysis, but I did just for your purpose. So if you are doing any project on sentiment analysis, so you can use this technique. Yes, so I'll ask the question.
Sir, can you scroll down
Hmm.
where you plotted the confusion matrix?
No, I haven't plotted confusion matrix. Just printed the confusion matrix. Here it
हाँ
is.
मतलब
Here it
yeah,
is.
yeah, I see that. So our use case is for sentiment
Hmm.
analysis, right?
Hmm. Yes.
So sentiment analysis, like how many labels are there? Like
Three:
there are three labels.
positive, negative, neutral. Zero, one, and
Okay,
two.
okay,
Three
okay.
labels are there.
Generally in sentiment analysis, there are either positive or negative now. So that's why I was
See,
wondering why
no,
there
so
is
neutral
reciprocity.
is also there. क्योंकि यदि आप if you are having a text data and if you are using one library that is called as SIA, sentiment analyzer, तो वो तीनों ही बनाएगा, पॉजिटिव, नेगेटिव, न्यूट्रल.
Okay.
हाँ, not only positive, negative, neutral is also there. और अदर
Okay,
यूजिंग
and
अदर
so
यू आर यूजिंग टेक्स्ट ब्लॉब, पोलैरिटी चेक कर रहे हो आप.
okay. And sir, can you please explain this function of this library bit and byte again?
हाँ, बिट एंड बाइट, बिट एंड बाइट वाला जो है, इट्स अ मेन ऑपरेशन. एंड आई ऑलरेडी टोल्ड इन द बिट एंड बाइट विच वी वर टेकिंग हियर. Okay, because if you are dealing with the LLMs now, whatever be the LLMs they are going to use, they are incorporating this bit and byte thing. So you are loading your model in 4-bit representation. Double quantization, I'm saying no, and I'm taking this 4-byte quantization only, NF4. Okay, and for computation, I am taking the data in 16-bit floating point representation. That's it. यही configuration है bit and byte का जब हम यूज कर रहे हैं. Okay, take the data
मतलब
in
इसका
16-bit floating point representation, load the model in 4 byte, 4 bit, and bit by bit आपको क्या करना है, कंप्यूटेशन करना है, bit by byte, bit by bit, you have to perform the computations.
तो मतलब इसका पर्पस बेसिकली बस ये है कि वो मॉडल का जो साइज है उसको कम कर
कम
देगा
करना.
ताकि कंप्यूटेशन में
हाँ
जल्दी हो
हाँ
जाएगा.
हाँ, जल्दी हो जाएगा, कम करना. ये पूरा
ओके.
काम कम करने के लिए हो रहा है. टू रिड्यूस द
Okay.
कॉम्प्लेक्सिटी ऑफ द मॉडल। चाहे आपने LORA लिया, वो भी आप समझ गए अब
Hmm.
LORA। आई गेस दैट वाज
Yes,
समथिंग
sir.
विच, है ना, नहीं पहली बार शायद हम इसको यहाँ पर लेकर आए। ठीक है, लो रैंक
Yes,
अडेप्टेशन
sir.
टेक्निक। ठीक है, तो आपने
Yes, sir.
प्रोजेक्ट में नए ही सीखा है।
जी जी.
ठीक है, तो वो LORA लेकर आए हैं, एंड देन ये बिट एंड बाइट वी डिड यूज इन लामा 2। ये जो आप पूरा कोड देख रहे हो ना, वी ऑलरेडी यूज इन लामा 2 फाइन
Okay.
ट्यूनिंग। ठीक है, वहां पर भी बिट एंड बाइट था, वहां पर PEFT था, TRL वॉज ऑल्सो प्रेजेंट देयर। Okay, that means training loop abstraction. So whatever be happening in the training, during training, whatever be the important events are been going on, just abstract, capture those important events. That is TRL. And PFT तो positional encoding है। Okay,
Hmm.
that means किस frequency से कौन सा word किसके साथ आ रहा है, with which frequency which
Hmm.
word is coming, तो वो है। तो मेरा उद्देश्य यहाँ इस कोड को समझाने का तो बिल्कुल था ही नहीं। आई हैवंट प्रिपेयर्ड दैट मैं इस कोड को समझाऊंगा, बस इसका कुछ एलिमेंट्स मुझे बताने थे आपको। ओके, फ्यू थिंग्स आई वांट टू एक्सप्लेन। जैसे वो बिट्स एंड बाइट्स हुआ, TRL हुआ, PFT हुआ, एंड ये ट्रेनर। लास्ट में मुझे ये बताना था कि टेक योर डेटा, स्प्लिट योर डेटा एंड पुट इन टू द ट्रेनर। इस ट्रेनर में रख दो आप, जो आपका फॉर योर पाई टॉर्च वाला है। ठीक है, जस्ट पुट दिस थिंग, जस्ट यूज दिस कॉन्फ़िगरेशन। ओके, so next time आपको obviously sentiment analysis is one of the thing which we are doing from the past in NLP. Now how to use Gemma for sentiment analysis, आपके सामने scores आ गए। This is what you can do। हाँ, so these are the results। Here is the result। Accuracy for label 1 is 96, accuracy for label 0 96, label 1 1, and accuracy for label 2 is 83, and overall accuracy is 84। This is the accuracy। Here is the confusion matrix। Okay, so that's what we did here in our project। Okay, I hope this makes a sense and effort for how to perform fine tune. What is Gemma model? What are the important elements which are present in a Gemma model? Okay, and how to perform fine tuning of a Gemma model. Okay, let me